This is question number 15 in paper 2, section C. So diagram shows triangle ABC, and the point D, E, and F, they are on the side of AB, BC, and AC respectively, such that we are given the ratio. So how do we fill in the ratio in the diagram? A to D, D to B. A to D is one part. D to B is two parts. Okay, I have the habit of writing the ratio in a number that is circled. Okay, all right, and then B to E is 8 cm. So B to E is 8 cm. Okay, it also given that AB is 12. Now from A to B is 12 cm. A to C is 7 cm. And can you see that? Since this whole thing is 12 cm, the A to B is being divided by 2 parts and 1 part. So 3 parts altogether. So 3 parts of 12 cm. 3 parts that could make 12 cm, each part will be 4 cm. So this one, when you times 4, you get 4 here. This one, when you times 4, you get 8 here. So you see 8 plus 4 is 12. So that is why I circled the ratio. So when I write the actual length at the side, then there is no confusion when I want to use the information from the diagram. Okay, so next part of the question will be, okay, we need to calculate the length of the length of EC. We need to find this. So how do we count? Can you see that we have an angle between the AB and the AC? So we can use the cosine rule, okay, to find the length. To find the length, only 2 rules. One is cosine rule, another one is the sine rule. Sine rule need two pairs of the side and its corresponding angle, whereas the cosine rule, we just need 3 sides and the angle. Then we can use the cosine rule. Okay, so let's find the EC. Now EC is part of the BC, so we just use this one. So BC squared will equals to the A squared plus the B squared minus 2AB cos 110. So this one, just use calculator. Let's see what's the answer. Yeah. So we have 12 squared plus 7 squared minus bracket 2 times A times B, and then times with cos C. C is 110. And that will give us 250.46. Yeah. Now let's square root it. We will have 15.8259. So 826 lah. Okay, now so from here, this is BC. So that is BC squared. To find BC, we just need to square root this one lah. Okay, and that is for B to C. And then from there, we can find the EC. EC will be 15.826 minus the 8 cm over there. So we will have 7.826 cm. So we found the answer for EC. Now what's next? Let's look at the question. It says, calculate the angle ACB. Calculate the angle ACB. So where's ACB? ACB is here. So this is the one that we need to calculate. All right. To calculate this angle, therefore we have to use the sine rule. Yeah. Now there are something in the middle. So let's just let me just sketch a very simple one so that our focus will not be distracted by the triangle inside the ABC. So we know that this is 110 and we need to find this, and we know that this is 12 and this is 7, and we just found that this whole thing is 15.826. Yeah. So with this, if we want to find this, we have to use the pair, the angle with its side and the angle with the side over here. Now, since that angle is the one that we want, so in our formula, we have to put it on top. So sine angle ACB over the opposite length is 12 equals to sine 110 over the BC, the whole thing, 15.826. So to find sine angle ACB, so rearrange everything using our calculator. We have 0.7125. 0.7125. Give our answer in four significant figure. And then from there, to find angle ACB, we reverse the function sine to the other side. Will be arc sine of 0.7125. So shift sine will become arc sine 0.7125. So we have 45.44. Let's change it to minute. So 45 degree, 26 minute. So we have 45 degree, 26 minute. Okay, let us continue with question number B. Now, it is given that AF equals to AC. I think there is some error in the question set over here. It should be AF equivalent to FC, because if AF equals to AC, I redraw the diagram. AF, if it is equals to AC, it's impossible because AC apparently much longer than AF, so it should be AF equals to FC, not AC. So in that case, 7 divided by 2, therefore, this will be 3.5 and 3.5. Now, we need to find the area of triangle EDF, right? Calculate the area in cm square of triangle DEF. So how do we find this? We can take the big triangle, cut away the first triangle here, second triangle here, and third triangle here. Because for each triangle, we can use the half AB sine C to find the area. Isn't it? We have the angle of 110. We've found the angle of C, which is 45.4. And this side, we can find by using 180 minus 110. That is 70. And then minus 45.4. So we will have 24.6. Okay, and then for this triangle, I have the two sides that is between this angle 24.6, and for this 45.4, I also have the two sides that make up this 45.4. So with that, we shall be able to find the area of triangle DEF equals to area of the big triangle minus the area of part 1, area of part 2, and area of part 3. So in this case, for the big triangle, we will have half AB, which is 12 times 7, sine C, the angle between these two sides, minus half. So triangle number 1, A is 4, B is 3.5. And then sine 110, and minus the second triangle, half. The A is 8, B is also 8, so 8 times 8 sine, the angle in between them, 24.6, and then minus half, 7.826 times 3.5, and then sine 45.4 degree. Okay, let's calculate this. Now for this, because we keep using the formula half AB sine C, so I can set the formula here, half times, now shift A times shift B, half AB times the sine C. Then we just key in what is our A, B, C respectively. So for the first part, the A is 12, B is 7, C is 110. So we will have 39. Take 4 significant figure, 4 decimal places. 4, 6, 7, 1. And then minus the second one. The A is 4, B is 3.5. C is also 110, so we have 6.57778, and then minus the third triangle, 8, and the C is 24.6. So we have 13.321, and then minus the A is 7.826, and then 3.5. And then the C is 45.4. So we have 9.7516. Okay, now take all these number and minus 39.4671 minus 6.5778 minus 13.321 minus 9.7516. So we will have 9 point, and round it off to 4 significant figure, 9.817 cm squared. So that will be the area of the triangle DEF. Now the next part of the question, it says, hence, that means continue with what we have found in part 1. Find the perpendicular distance from D to EF. D is over here. We need to find a perpendicular distance. That means it makes 90 degrees to the EF, right? So we have the area of DEF. It's also equivalent to half times base times the height here. So let the perpendicular distance to be H. And do we have the base here? Oh, we need to find then. We need to find this one, yeah? Okay, how do we find the EF? How do we find EF? We have 7.826, right? And 3.5. So we can find EF first. So EF equals to square root of, okay, we use cosine rule. So EF C squared equals to A squared plus B squared. So our A will be 7.826 squared plus B squared, which is 3.5, minus 2 times AB, 7.826 times 3.5, cos C. The angle is 45.4. Okay, so with this one, let's use the calculator. We have 7.826 squared plus 3.5 squared, and then minus 2 times 7.826 times 3.5 times cos 45.4, close bracket. And then we have 35.0309. Don't forget, we have to square root this one, 5.919. Okay, so EF is 5.919. 5.191. 5.919. Okay, so that is EF. So once we have the EF, so this will be the base of the triangle. So let's put back half area of DEF will be half times the base, which is the EF, times the height. And the area of the triangle that we have just found is 9.817 9.817 equals to half. EF is 5.919 times the H. So H will equals to, let's rearrange this equation. So we will have 9.817 times 2 and then divided by 5.919. So our H will be 3.317. 3.317. So we have just found the perpendicular distance from D to the base EF here. Okay, so that's it for question 15.